As promised, back with part 2 of the Chapter 7 review. This time we're looking up here at this little purple box there. Sketching y equals a outside of x minus h all squared plus k, better known as the turning point form. I've got a little example a bit further down the page here, but let's just make sure we know what we're in for when we do these ones. So the turning point form. Whoa, that's a bit weird, isn't it? I think I held down the wrong button. Turning point form. That's looking a little bit nicer. So what is it we need to know about the turning point form? When I have y equals a, remember multiplying by a number just dilates it vertically, so you get that sort of stretch happening vertically. It can change some of the points, but not much else. It doesn't really make it too hard to do the equation, so let's get rid of that one. So we've got x minus h all squared plus k, and of course what's the important thing, the important feature about this? It's called the turning point form for a reason. The turning point is just h k. It's that easy. How do we remember this? Well, remember, if I just add a number at the end of an equation, what does it do? It adds a number to every point. And what points are they being added to? To the y, because see how that's y equals? So adding a number adds values to y, so everything shifts up by whatever that number k is. When I subtract a number from h, it actually moves it in the opposite direction. So if I subtract a number, I move to the right, which looks like the left on the recording, so I'll have to get my hands backwards. That'll confuse you. Maybe I'll go without the hand gestures. That's pretty funny. If I go with h, if h is negative, it moves to the right. If it's positive, it moves to the left. Basically, when you've got something inside brackets happening to just one letter, so even if I put k on the other side and put it in brackets with the y, then it would be y minus k would be moving it to the right, just as it is when I add it on that side. So it's going to move the turning point to hk, and then you sketch it the same way, find the intercepts the same way. Everything else is as easy as it always has been. Let's start with this one. It says to do this by completing the square. Yes, you still need to remember how to do this. When we're completing the square, let's just remind ourselves what I'm trying to do. I'm trying to get something in the form of a squared plus 2ab plus b squared. Why am I doing that? Because then I've completed a perfect square. I can factorize it easily. Otherwise, if it's not a positive, it's a negative. I get negative 2ab plus b squared, and that factorizes into a take b all squared. Same thing, ready to go. We've got something factorized. We can get it in a turning point form, make our lives easy. Let's go with this first one over here. Whoa, how did I do that? Let's Control Z that. Oh, that worked. Sort of. I just have to scroll down a bit more. There we go. Let's try again. So we've got y equals x squared take 4x plus 1. So I'm going to rewrite it. X squared minus 2 times x. What's the other number that I need in there so that it's still equal to 4x? It must be 2. Here's where I cheat and add on a little bit. So I add on 2 squared. That's now completed the square. I've got something in the form that I wanted over here, a squared minus 2ab plus b squared. But I cheated by adding on 2 squared. So I have to subtract the 2 squared, and I've still got that plus 1. So, still got that plus 1, which made it the negative 3. So there we go. We got y equals x minus 2 all squared minus 3. That's what it simplifies to. The bracket simplifies to the first bit. Negative 4 plus 1 gives me negative 3. So we can go ahead and write the turning point. Now remember the turning point x minus h. So it's just the 2 that's the x coordinate of the turning point there. The y coordinate of the turning point is negative 3. 2 and negative 3. So once we've got the turning point, we could sketch this really easily. Put in our set of axes. When x is 2, y is negative 3, so it looks like about there somewhere. It was a smiley face one. What's the last thing we might want to look at? Label all key features. Well, I know that the y-intercept is actually a positive 1. When I sub in 0 or just the number on the end, I get 1. So now I get an idea of the shape of it. Label my axes, and I'm done. For some of them, we'll get you to label the intercepts. For this one, looks a bit tricky. If I was going to label the intercepts, what would I have to do? I would actually have to keep going with my completing the square and use the null factor law. You can see if I keep going with this, I could write y. Now I've got my favourite rule in maths. It's x minus 2 plus root 3 x minus 2 minus root 3, which of course would give me my intercepts. Therefore x equals 2 take root 3 or 2 plus root 3, and they would be my intercepts. That would be the 2 take root 3, and that would be my intercept 2 plus root 3. Usually in an exam, especially at the start or with the parabolas, we'll either give you numbers that are nice, or you will tell you that you need to label the intercepts. If they're complicated ones like that, we may not get you to. But having said that, that's just a quadratic formula or a simple procedure of using your favourite rule in maths, difference of two squares, so either one would work. It's not really an issue. That's how you go ahead and do them. Complete the square. I'll leave you to do the other one because we've got a couple more videos we want to get through, but hopefully that helps you out a bit for now. Cheers.